Right, here are the solutions to this pure test. I've taken the questions from the practice papers that Edexcel produced in 2019, so they should all be of approximately the correct standard. Here's question 1. We have to integrate these three terms. 6 over x is 6 ln x, 3 over x squared goes to minus 3 over x, and this goes to 2x to the 7 halves. In part B, we've got to put in 9 and 4 into this expression. We can ignore c because it's now a definite integral. 6 ln 9 minus 6 ln 4 is 6 ln 9 over 4. Subtract lns and it becomes a divide. You can leave it like that, or 9 over 4 is 3 over 2 squared. 3 over 2 squared, so the 2 comes down with the 6 to make that a 12. Question 2 is a proof by contradiction. So firstly, we'll assume that there is a finite amount of prime numbers, not an infinite number. We write out all the prime numbers, there's n of them, and then multiply all those numbers together and add 1. Now when that number is divided by any prime number, there's going to be a remainder of 1. So that means n is either prime, or it has a prime factor, which is not one of those. So neither of those statements is consistent with the original assumption. These are the prime numbers, so n is not one of those. Or n is a prime number, but it isn't because it's bigger than these numbers here. So there's a contradiction, so therefore there is an infinite number of prime numbers, and you do get 1 mark for writing the conclusion at the end. Now I've got question 3, and we've got these parametric coordinates, and we need to form a Cartesian equation. So from here, t equals x over 8 minus 10, so we can get an expression for t, substitute that in for t in the y expression, and simplify it to get this. Now in part B we want the width of the arch, so if we think about the arch being like that, then the width of the arch is that distance there. So that occurs when y equals 0. So imagine we've got the x-axis here and the y-axis there. So these points occur where y equals 0. So if y equals 0, then 100 minus t squared is 0, so t is plus or minus 10. Put t is 10 or minus 10 into this expression, and we get 0 and 160. There's an alternative way of doing that. It's where the y part of this expression equals 0, so we could just solve where that equation equals 0. It's where y is 0, solve that equation, and we get the same answers, 0 and 160. Now the greatest height occurs where dy by dx is 0, it's like a turning point. So it's at the turning point here, so that's where dy by dx equals 0. So let's differentiate the expression for y here, put it equal to 0, solve the expression, and we get y is 100, which is the greatest height. You could think about the fact that the greatest height occurs at the centre of the arch because it is symmetrical, it's quadratic, so it's at that point there. This was 0, this was 160, so it's where x equals 80. So we could do it in that way, and we get the same answer. When x equals 80, put that into the expression here, and we get the same answer. Question 4 is just one of those proofs that you need to learn. You get 1 mark for writing the general formula here. Substitute in fx equals sine x, so fx plus h is sine x plus h. Expand using the double angle formulae. Then the little trick is this bit here, which they told you that because you had to prove that part here. So if we take the first term and the third term, those two terms, sine x is a factor. That leaves cos h minus 1, and then we get this bit here. So then we need to write it out in the format they've got it. In part B, where we need to actually do the get the differentiation for first principles, as h tends to 0, cos h tends to 1. So if cos h tends to 1, cos h minus 1 over h tends to 0. And as h tends to 0, sin h tends to h, sin h over h tends to 1. So this bit's 0, this bit's 1, and we get cos x. So this is a standard differentiation from first principles, which you just need to learn. Now in question 5, I'm a bit puzzled because it seems quite a straightforward, easy question. The mark scheme has a much more complex proof, but this proof is easier in my opinion. So I've just labelled this bit B and this bit A. Tan theta is B over A. So 1 plus tan squared is 1 plus B squared over A squared, which simplifies to be that. But A squared plus B squared is 1 from Pythagoras. Just wrote Pythagoras there. So 1 plus tan squared is not A squared plus B squared, it's 1 over A squared. Now we need to show that 1 plus tan squared is sec squared. So let's think about sec squared. Well, cos theta is A over 1. So sec is 1 over A. Sec squared is 1 over A squared. So those two are both 1 over A squared. So 1 plus tan squared equals sec squared. So in my humble opinion, that's 8 fairly straightforward, easy marks. Now in question 6, we need to find a local maximum. So we take this expression, differentiate it, and put it equal to 0. So differentiate a ln, it's 1 over that. Cos goes to minus sine. Put in 8.5 and 8.6. One's positive, one's negative. There's a change of sign. The function is continuous. So the gradient is 0 in that interval, and so there's a local maximum. Now in part B, the local minimum occurs when p dash t equals 0, similar to this. So we need to solve this equation. So to use Newton-Raphson, which we're going to do down here, we're going to have to differentiate again, and then it's p dashed of 9.9 over p double dash of 9.9. So this is this expression differentiated, and you put in 9.9 to get 9.959 as the solution. So I think the only tricky part with this is to realise that we need to solve the equation where p dash t equals 0. So it's similar to this. This bit we solve by putting in the bit below and a bit above. This bit we're going to solve by Newton-Raphson. And now question 7. We're told that the rate of decrease of value is proportional to the remaining value. So the rate of increase is dv by dt. The rate of decrease is dv by dt, that's going to be a minus number. It's proportional, so that's k, the remaining value is v. So separate the variables, the v goes down here. And the k you can put where you like, I've just left it at the top, that seems easier. So integrate 1 over v, that's ln v, integrate 1, that's t, don't forget the constant. Inverse of ln is e. And so we've got e to the minus kt plus c, so that simplifies like this. E to the minus kt times e to the c. E to the c was written as v0, and there's your solution. In part B, we're told after 10 years the value is a fifth v0, so let's put that in there. T is 10, v0's cancel, and then we get k is that or that. A fifth is 5 to the minus 1. That's obviously easier, but this will do as an answer. And now in part C, we've got 5% of the original value. So 5% is 1/20th, so v is 1/20th v0. Put that into the expression that we've got here. There it is. So v is 20th v0. The v0's cancel. We know what k is, so we can work out what t is. And that's it.